All right, hello, math fans. All right, so this is our last unit here, and these are some applications of square roots. So we're going to talk about something called the Pythagorean Theorem today. Very, very important. Okay, so a couple things. First of all, you use the Pythagorean Theorem, so use only with right triangles. And what I mean by right triangle is a triangle with a right angle. And you guys probably should know a little bit about this, right? That has a right angle. It's a 90 degree angle in that triangle. So you can only use it for right triangles. All right? So let's talk a little bit about some of the different sides here. So here's your triangle. Okay? And we're going to call this side A, this side B, and this side C. C, and we usually use the letter C for this, is called the hypotenuse. Okay? It is a couple things. First of all, it's across from the right angle. And what I mean by the right angle, or across, I mean, is here's the right angle here. It's across from it. So basically, if it's across from it, it doesn't touch it. That's another way to look at it. So across from the right angle doesn't touch the right angle. Okay? Okay, another thing about the hypotenuse, it is always the longest side. That's a huge thing too. Always the longest side. Okay, so those are the things that you really need to know about at least C. A and B, these are called the legs of the triangle. Legs of the triangle. And of course, I'm not going to write it out there, but they're shorter than C. A is shorter than C, and B is also shorter than C. Not combined, but each one separately is shorter than C. Okay, so those are here, legs of the triangle. Okay, so let's use a formula now that we have all that information. The formula we're going to use, and this is actually what Pythagorean Theorem is. It's a squared plus b squared equals c squared. Very simple, but it's used a ton in geometry. A ton. 2,000 pounds worth, okay? It's really, really, really important in geometry. All right, so let's just remember, though, you've got to remember which one's A and B. Now, A and B, I should have mentioned that. A can be switched with B, and B can be switched with A. It doesn't really matter where A and B are, but they are the legs of the triangle, and the hypotenuse, which is C, is always across from the right angle. Okay, so let's kind of start out with a nice friendly problem here. So I'm going to give you, sometimes I'm going to give you a picture, sometimes I'm just going to tell you what A, B, and C are. So if I give you a triangle, nice right triangle, and I tell you this is 3 and this is 4, and I want you to find the value of C. Okay, well, you're going to set this up as, I can say this one's A and this one's B. Doesn't matter as long as C is across from the right angle. So it's going to be 3 squared, which is A squared, plus 4 squared equals C squared. Don't forget the C squared. Don't just say C. All right? And now you're going to multiply it out. And guys, this is like the worst thing you could possibly do. It's super, super brutal. Is just to take the square root and go, oh, C is equal to, if I take the square root of both sides, this is bad. Don't do this. C is equal to 3 plus 4, or 7. That is the worst thing. Terrible thing to do. Boo. All right. This is what you need to do. Let me write this out again. 3 squared plus 4 squared equals C squared. You want to combine these together. So you want to say 3 squared is 9 plus 4 squared, which is 16, equals C squared. Combine it. So 25 equals C squared. Now you take the square root. After it's all put together, kind of that you just have a 25, you take the square root of both sides, and you get C is equal to 5. Now most of you guys are saying, well, hold on a second here. Isn't C equal to plus or minus 5? Yeah, when we're solving an equation it is, but you need to remember that these are lengths of a side of a triangle. Okay, so you can never have a negative length. So C is equal to just 5. And that's the answer to that problem. It's that easy. All right. So I know I spent a lot of time in that one problem, but let's do a few more here. All right, so here's another triangle, and this is going to be 4 and 6, and I want to find C. Okay, so it's a squared, so 4 squared plus 6 squared equals C squared. All right, so 16 plus 36 equals C squared. So I'm going to move the C squared over. I like it on the left-hand side anyway. Is equal to 52. Now that's not a perfect square, so we're going to use all of our knowledge from just the last chapter how to deal with a square root of 52. Well, I'm going to divide that by 4, and if I divide it by 4, I get 13 times 4. So then that's just, you pull a 2 out, and so you get C is equal to 2 root 13. That's an exact answer. Okay? That's pretty mellow. Let's do a few more here. This is going to be 8, and this is going to be, we'll make this one 4, and we want to figure out the value of B. Okay? No big deal. It's a squared, so again, label it if you want. That's kind of nice. So 4 squared plus, now we're looking for B. So 4 squared plus B squared equals 8 squared. Okay, so what's 4 squared is 16 plus B squared equals 64. So we're going to subtract 16. Remember, we're going to isolate that B squared. So B squared is equal to 48. Take the square root of both sides. And I got B is equal to, again, I'm not going to use plus or minus. And 48, however you remember that, but the simplest way of 48 is 16 times 3. If you did 8 times 6, that's bad because it's not a perfect square. If you did 4 times 12, that's okay. Because you could say, well, isn't 12 4 times 3? And that's the same thing as 16, right? So you pull a 4 out, and you have 3 left over. And that's the answer to that problem, 4 root 3. Not bad. Okay, let's try another one here. Well, instead of me giving you a triangle, I'm not going to do that. I'm just going to say A is 7, B is unknown, and C is 9. Okay, no big deal. Just kind of put it together here. It's A squared, 7 squared, plus B squared equals 9 squared. So 49 plus B squared equals 81. Subtract 49 from both sides. And we get 2 and a 3. So B squared is equal to 32. And then, of course, that's 16 times 2, right? And so you can pull out a 4. So B is equal to 4 root 2. And you can't always simplify it. Like let's just do another one here. What happens if I give you A is 4, B is 7. Find C. Well, that's 4 squared plus 7 squared equals C squared. So 16 plus 49 equals C squared. So that's going to be 65, right? Equals C squared. And I would take your calculator and see 65. What goes into that? Well, 9 doesn't. 49 doesn't. I know an even number doesn't. So 4 doesn't. 25 doesn't. So I can't do anything with it. So I still have to take the square root of it. All right. So C is equal to the square root of 65. All right. That's pretty easy. Let's do one with a variable in it now. It's a little tricky, and the question I'm going to ask you is this: find the lengths of the missing sides. And here's your triangle. So this is x plus 2, and this is 2 root 5. All right, and it's a right triangle. So, same deal, man. It's a squared, so this is a, and this is b, and this is c. Right? A, b, and c. So it's x squared plus x plus 2 squared equals 2 root 5 squared. Now, it's the worst algebra mistake that you could possibly make. It's something that we've stressed like for I don't know how many months. Okay, when you have that squared, you have to write it twice. If you don't write it twice and you just put x squared plus 4, you might as well retake algebra next year. Okay, because you didn't learn anything. So you need to write it twice. So I'm going to write it twice right here. So x plus 2, x plus 2. So x squared plus x squared plus 2x plus 2x plus 4. And then 2 root 5. Remember, 2 squared is 4. Root 5 squared is 5. So if I combine some stuff, I get 2x squared plus 4x plus 4 equals 20. I'm going to move that 20 over. And I get 2x squared plus 4x minus 16 equals 0. I'm going to factor out a 2. I get x squared plus 2x minus 8 equals 0. And then I factor that. I get x plus 4, x minus 2. So I get x plus 4 equals 0, x minus 2 equals 0. So I solve and I get x equals negative 4 and x equals 2. Well, remember I said find the lengths of the missing sides. So you need to understand, let me draw this a little bit cleaner here. This is x plus 2, this is x, and this is 2 root 5. If I plug a negative 4 into there, that doesn't make sense. You can't have negative 4 length. So this one is not even a solution. Okay, now that's great. If you put x equals 2 in the answer blank, you'll get a lot of the credit, but you won't get full credit because I'm asking you for the lengths of the missing sides. So that means you put a 2 into here. Well, what's one? So what you're going to have is you're going to say, well, 1 is 2. Isn't that what x is? And here, what is this one? Isn't that 2 plus 2? Which is 4. So the lengths of the missing sides are basically 2 and 4. X is equal to 2, but you need to plug it in to find the values of those sides. All right, so you just need to be careful about that. All right. The last kind of problem that we're talking about here is I might ask you, is this a right triangle? All right, is this a right triangle? And what I'm going to do is I'm going to give you measurements of sides. So I might give you like 2, 3, and 4. I'm going to say, is that a right triangle? Well, how do you know which one? How do you know what to plug in? Well, you should know that A and B are the smallest sides, and C is the largest side. So that's got to be C, and it doesn't really matter which one A and B are. I'm just going to do it like that. And then you plug it into the Pythagorean Theorem. So 2 squared plus 3 squared, let's see, does it equal 4 squared? If it does, it's a right triangle. If it doesn't, it's not a right triangle. So 4 plus 9 equals 16. 4 plus 9 is 13. 13 does not equal 16. So the answer is no, not a right triangle. Okay, let's try another one here. 3, 4, and 5. Is that a right triangle? Well, let's try it out. Again, that's A, that's B, and that's C. So 3 squared plus 4 squared equals 5 squared. So 3 squared is 9 plus 16 is 25. 9 plus 16 is 25. So yes. Okay, let's try another one here. 5, 13, and 12. Okay, well, A is 5, B is 12, C is 13. So 5 squared plus 12 squared, does that equal 13 squared? Well, 25 plus 144. Use your calculator. 13 squared is 169. 25 and 144 is 169. Sweet. So again, the answer to this one is yes. All right, that's pretty much it for doing your homework. Hope you guys hope you learned it now, because as I said, you're going to use this a ton next year. Well, you're going to use it on the quiz coming up on the final exam, and a ton next year in geometry. All right, that's it, math fans. Have a good day. Goodbye.